So next I'm going to go through a Simulink example problem here. So the problem we're going to take a look at is for a cam-driven system. So if we consider this system shown down in the figure below here, the motion y produced by the cam profile is often described by a polynomial. So the engineer wants to predict the mass displacement, or x of t, for chosen values of the stiffness k and our damping c. So we'll take the simple example here and suppose the displacement y is described by the simple polynomial y of t is equal to negative t squared plus 5t for values for time from 0 to 5. They're going to give us values here. M is equal to 0.125, our c is equal to 0.75, and our k is equal to 1. So we can see down here we have our mass, our spring, our damper here. Here's our y, and here's our x value here. So as we plug in our values for m, c, and k, we end up with this expression here, that 0.125 x double dot plus 0.75 x dot plus x is equal to our y here. So we're going to use three new Simulink's blocks for this example here. The first one we're going to take a look at is the LTI system block. This comes from our control systems toolbox library. Then we're going to take a look at our polynomial block, which comes from our math operations library. And last, we'll look at our clock block, which comes from the sources library. So this is our general system right here that we're going to do out in Simulink, and we want to figure out where each of these blocks come from. So if we go to our Simulink library browser to start with, and we go to sources, and then we go to clock, we can find our clock function. If we go back to the browser, we go to math operations, then polynomials, we can see our polynomial here for this block. Then we can go from our Simulink browser, we look at our control systems, and within control systems here, we go to our LTI system for this block here. And then to get this guy here, we go to our main browser, signal routing, MUX, in order to get this block. And lastly, we go to our browser, go to Syncs, Workspace, and we end up with this guy here that we can click and drag in. So that's just a quick overview on a little flow chart here to figure out where we go within Simulink to find each of these. So I'm going to go through here from the beginning in MATLAB. I'll type in Simulink. This will open up our Simulink window here. So now we can see we want to go, if we come down here in Simulink, we can look for our blank model. So we can double click on that to create a model here. This will pop up now for a blank new one. Go up to our library browser. Within our library browser, we can bring this over here, and we can see we go back up to Simulink. Scroll down through just like we saw on the previous slide here to our sources, find our clock source. We can click and drag that into our window. Change the size a little bit, position it where we want it. So now we have our clock function there. Go back up to our library browser. Go through the next step. What was the next thing we need? We'll go to math operations. Within math operations, we'll go over. Scroll down a little bit. We see our polynomial block. Click and drag that in. Reposition, resize that. Put that in our window here. So now we've got both of those guys all set up. Go back to our library browser. Come back over to Simulink. Now we'll go down to our control systems toolbox. See our LTI system. Click and drag that in over here. Reposition, resize that. Get that into our window. Then we can go back up to our library browser. Back to Simulink here. Go down to our signal routing. Look in here, signal routing. Plug in MUX. Pull that over here. Resize, reposition that back into our window as well. Back up to our library browser, down to our syncs, our sim out to workspace here, plug that in, resize and position that in our window as well. Now we can connect all of these. Go through from each block, click and drag. Last line there, click over here, bring this up and over and in. Now we have our basics that we saw in our initial diagram here in the problem statement within Simulink. So now that we have the Simulink model here, let's talk about a couple of these things and what we're going to need to do. So we'll take a look at our clock block first. Now this doesn't require any parameters to be set, so we can leave that. Next, we'll take a look at our polynomial. So this provides the simulation time from our clock block going into our polynomial block there. So within this one here, we're going to open this block and enter in -1, 5, and 0 for our polynomial coefficients that correspond with our equation. So we'll go back in, take a look at our clock. Again, this doesn't really require any parameter changes, so we can leave that. This is going to send the time over to our polynomial blocks. We'll double click our polynomial block, take a look at our coefficients here, delete the given ones that are there, and plug in our new ones. So we'll put our -1, 5, and 0. Type those in for our coefficients, hit apply. Okay. Now, reminder, don't forget to change the save format to array in our workspace block. So we'll go to our workspace block here, take a look down, make sure that this is set to array, hit apply, okay. Now, before opening our LTI system block in the command window, we're going to enter the model's transfer function as given below here. So SYS is equal to TF, parentheses 1, comma, and then right there our 0.125, 0.75, and 1 right there. So what we're going to do is go back, enter this into MATLAB right there, plug in that function right there, SYS is equal to TF, parentheses, 0, and we put in our 0.125, 0.75, and 1. Run that. Now you can see over in our workspace here we have our SYS. So now we can go back into our LTI system block now that we have that already programmed in and enter SYS into the LTI system variable window. So this method is going to allow you to easily change the system model in the command window without having to reopen our LTI system block. So we can just go in and change that if we need to change our parameters under those values. So we go in here, double click on our LTI system block, change this to SYS. You can see it pops up right there from our workspace. Double click that, make sure that's good, hit apply. Okay, now we're all set. So the alternative is we could type this into our LTI system variable window right there rather than the SYS. Do not need to specify any initial states because this option is available only if the model is in a state space form. So if we were to do it that way, just show you, instead of system there, we could go in here and type in that function that we just typed into our workspace before, put that in there, hit apply, and OK. Now, we can run the model next, which we've given the name CAM system here. So we can come up, save as, give it the name. Okay, I've already named it, so we'll just save it over it again this time, replace it, no problem. Then we'll come over here up to run our system there. We can go back, and now we can see in our workspace over here, we have our outputs there. Now, to illustrate the usefulness of this LTI system block, we can create the following script file here. So I have this little script that I wrote up now. So there's our SYS right there, sim for our CAM system, and then we're going to plot our results there, and we're going to set some X limits and some Y limits here. So let's run this script file. So we put this in. We're on our script file here. We have our program name, a little description. Go through our plot functions here, our x and our y limits. We'll run this. When we run it, we'll get the following plot to come up here. So we can see for x and for y, we have the following plot, and we can see we have our x and our y limits on this graph here that we programmed in from 0 to 5 and 0 to 7. And here's a little bit closer version of this plot that we saw here for our x and our y, again with those same limits that we programmed in.